Hi everyone, this is Mehul Mehta and welcome back to my YouTube channel. So in this video, I'll be helping you understand how can we model yield curve using cubic spline interpolation. So in this video, I'll be actually walking you through, a Python implementation of modeling the yield curve using cubic spline. Also, if you have not seen my previous videos on modeling yield curve using Nelson-Siegel method, Nelson-Siegel-Sevenson method, and the linear interpolation method, I highly recommend to watch those first and then jump onto the cubic interpolation. But let me get started. So see, the thing is, the question is, why do we need to understand cubic spline interpolation? What's the need of it? So the thing is, cubic spline represents the yield curve in a better way, or you can say that when it comes to accuracy, right? Or when it comes to depicting the true nature of the yield curve, cubic spline interpolation does a better job than all the previous, like linear interpolation, Nelson Siegel and the Nelson Siegel Stevenson. So cubic spline wins the race among all those other methods. So first of all, what is a cubic spline interpolation? See, if you see, let's say we have these 2 points. Let's say we have certain points like this. You see this point, this point, this point, this point. And similarly, let's look at this, this picture of linear interpolation. So here it's written linear spline, but it's actually a linear interpolation. So just, I got this image from online resource. So just remove this, don't consider this spline. This is nothing but a linear interpolation. So the main difference between a linear interpolation and a cubic spline interpolation is nothing but basically, if you see here, what a linear interpolation does is between 2 points. Let's say if you see between 2 points, it draws a straight line. Between 2 points, it draws a straight line. And that's what you see. But on the other hand, what cubic spline basically does is it does not draw a straight line. Instead, what it does is basically it draws a curved line. So if you see, any cubic spline interpolation, if you see any cubic spline interpolation methodology, it will draw it will draw a curved line instead of drawing a straight line between 2 points. What you see here, it will draw a curved line. So that's how, even if you see the final picture that we have got, if you see, these are curves, these are the points that we are getting are, curves. This line is more curvy in nature as compared to a straight line. So that's the main difference between a linear interpolation and a cubic spline interpolation, that instead of in linear interpolation we have like a straight line between 2 points, but in cubic interpolation we have like curved lines between 2 points. This is more from a interpretation point of view, but again the math goes, in the mathematical piece we do, there's a lot of math involved behind the cubic spline interpolation too. But this is how you can, visually see the difference between the cubic spline and the linear interpolation. So let's get started. Let's see how can we implement the cubic spline interpolation using Python. So see, the first step is to, to get all the libraries. If you see, the main libraries that we require for this process is NumPy, matplotlib.pyplot, and scipy.interpolate. NumPy is nothing but we need this library to work with arrays. Matplotlib is a visualization library, so it helps us, build all the different kind of charts, line chart, bar chart, different kind of charts. It is required for visualization. And similarly, this scipy.interpolate, this is basically, you can say that, this is a scientific library in which different interpolation techniques like cubic spline, linear interpolation, and there are many more interpolation techniques which are stored. So what essentially we are saying here is import numpy as np, okay, which basically means that, okay, instead of using numpy everywhere, we'll just use a short name which is np. Similarly, import matplotlib.pyplot, so and import this as plt. So we are just saying that instead of using this full name, we'll just use a short name which is plt. And so this is, this we are saying that we are giving these as short names. And from scipy.interpolate import cubic spline. So what we are saying is from this package which is scipy.interpolate, just import this specific cubic spline methodology. Okay, so from this package we are importing cubic spline. Why? Because this is what which we will require in our process. So this is nothing but we are importing all the necessary libraries for building our Python code. Now the next step is to basically, give the maturities and the yield. So if you remember the Excel implementation, if you have seen my videos of linear interpolation, you know that, we were trying to basically, this was our given data, right? For this specific day, right? This was our given data. So 4.72, 4.72 up till 4.44. So these were the maturities, and these were the different yield curves, right? And similarly, if you ask me, so as I said, I get all my data from daily treasury power yield curve, right? And specifically, if I look for this date, which if you see even in Excel, this is the date I was referring to. So this date, if you see, we have, these are all the data points that we require for modeling the yield curves. So if you see, basically, we have this these are different maturities. So this is nothing but the yield at this maturity, yield at this maturity, yield at this maturity. So what happens is, this is the data that is given to us, and similarly for the date that we have, this is the data that is given to us. And what we are trying to find is, we are trying to find the in between maturities. If let's say we have, let's say, now if you see here, the fifth month is missing, the yield for 4 month is given, and 6 month is given, but the for the yield for fifth month is not given. Similarly, if you see here, the yield for 7 month, 8 month, 9, 10, 11 month is not given. So these are the data. So these are the maturities. So we are trying to find the yield at in between these maturities. So similarly, if you see 20 to 30 years, there are so many years missing: 21, 22 year, 23 year, 24 year, and so on, right? So we'll try to build a process which can find the in between yield for these maturities, in for the missing maturities. So what essentially we do is, what we say is, let's say, this is the data that is given to us. So the way we write is, we say that, let's write this in an array form. So NP is nothing but our numpy. So basically we try to store this in an array format, the given data. So this is 1 month, and as I said, always remember, when the maturities are in months, we need to convert those into years. Okay. So one month is 1/12, 2 month is 2/12, 3 month is 3/12, 4/12, 6/12, and the years are in the same format. Okay. So the 1 year, 2 year, 3 year, these will always remain in the same format. And similarly, these are the yields that are given: 4.72, 4.72 for each. So basically we are saying that the 1 month, for the 1 month, the yield is 4.72. For 2 month, the yield is 4.72. For 30 years, for 30 years, the yield is 4.44. And this is, if you remember, this is the data that is given, right? So this data again comes from what, this website, right? If you see, this is nothing but, this data comes from this website. Yeah, so if you see 4.44, 4.55, 4.26, so 4.44, if you see 4.44, 4.55, 4.26, so this is nothing but, this is the original data that is given to us. So what we basically do is, we basically call this method, which is the cubic spline method. So we just, we are using this method. What we are saying is, okay, let's train our cubic spline. Okay, let's train our cubic spline. So what we do is, how will we train? We will definitely give what, the x point and the y point, right? So maturities are nothing but this, we say that, okay, these are our initial maturities, and these are the yield, these are the yields which correspond to these maturities. So what we are doing here is, we are just training our cubic spline methodology, giving the maturities and the corresponding yield, and we say that the trained cubic spline is nothing but CS. Okay, the trained cubic spline is nothing but CS. Okay, so we are just we are just training our cubic spline method, giving these maturities and these yield. And then the next part is, of course, we need to find, if you remember, what was the next part? We need to find the in between maturities. These, there are so many maturities which are missing. Even, like, let's say, between 7 year and 10 year, 8 year and 9 year are missing. Between 10 year and 20 year, 11 year, 12 year, 13 year, 14 year, 9 up till 19 year is missing. So what we are doing is, we are just saying that, let's give all the maturities for which we need to find out, right? So let's say 1/12, 2/12, 3/12, these are all given. But if you see, 5/12 was missing. If you see, between these 2 points, 5/12 was missing. And similarly, between these 2 points, 7/12, 8/12, 9 by 12, 10 by 12, 11 by 12 was missing. So we are just saying that, wherever we are, let's try to, let's give all the possible maturities which at which we need to find our yield. Okay, so let's say, even between 20 to 30 years we have defined all the different maturities. Between 10 to 20 years we have defined all our maturities. Okay, so basically now what we are essentially saying is these all are our maturities, and we need to find the yield at these maturities. So as you remember, we have already trained our method CS, we have already trained our cubic spline interpolation methodology. So what we are saying is now just apply this trained cubic spline to the new maturities, to this maturity. So what will happen is, once you give these maturities, it will automatically give you the yield. Okay, it will automatically. So this method, this cubic spline method, when you give the maturity to it, it will automatically give the yield to it. So these are the, basically, if you see here, these are nothing but these are the yield which are associated. Okay, these are the yield which are associated with all these maturities. So essentially what we did was we have basically calculated the yield at all the points using cubic spline interpolation. Also remember one thing, even though we have given C 1 by 12, what was the yield at 1 by 12? It was 4.72, which is what you see here. Similarly, what was the yield at 2 by 12? It was 4.72, and similarly what you see here. Similarly, let's say 6 by 12. If you take any data point, you'll basically, let's take 6 by 12, the corresponding yield is nothing but 4.39, and that's why for 6 by 12 you see the yield is 4.39. So these yield will remain the same. The yields at these points will remain the same. Only what the method does is it will try to basically find out the in between. It will try to find out the in between maturities. Similarly, for 30 years, you see what is the yield? 4.44. And here also for 30 years you see 4.44. So basically what the CS method has done is, the first what we have to do is we have to train our cubic spline interpolation method by giving the maturities and the yield. And once we have given the maturities and the yield, the next step is to predict the in or interpolate the in between maturities. So we'll give all the necessary maturities, and that's it. We'll give the CS method and say that, okay, find the yield at these maturities, and these are all the yields at these maturities. Now the next step is nothing but we need to draw, or you can say, basically, let's draw the diagram for how the cubic spline interpolation looks like. So what we have done is we have just, if this is nothing but a matplotlib library. Okay, if you remember, what we have done initially was we have imported matplotlib as plt, right? So we are saying that matplotlib.pyplot is nothing but plt. And as I said, if you are familiar with Python, you might know this already, that matplotlib is used to, matplotlib is nothing but it is used to build line charts or different kind of charts. It's a visualization library. So what we are saying is, first, my figure, plt.figure fixed size is equal to 10 comma 6. So the first thing that the code says is my figure size should be 10 comma 6. Okay, then it says that plt.plot. Okay, what do I need to plot the maturities and the yield corresponding to it. So what it will do is it will plot all these things. Okay, it will plot these things, maturities and the corresponding yields. Okay, it is plotting maturities and the corresponding yields. Okay, so whatever you see here in the black dots, these are your maturities and the corresponding yield. Okay, and then the next thing is nothing but let's plot the new maturities and the new yield. So if you see, even though okay, let me show if this works. Let me put star. Yeah, so if you see what has just happened, all the in between maturities are now plotted, right? All the in between maturities are plotted, but I feel a better way of representing this is in a dash format. But I just wanted to show you, each dash represents the maturity. Okay, so don't think that, okay, there's just a dash. I mean, of course it's a dash, but um, if you see, if I just put it to star, that's where you will understand, that, okay, we are basically this. If you see these stars, these are nothing but all those maturities which were missing, right? So if you see between 20 year to 30 years, these were all the points that were missing, and that is what is, if you see these 20 year, and 30 years. So all these points represents what? All these points represent the yield at the in between maturities. Okay, so guys, this is how, basically we can plot the diagram, and this is basically labeling your x-axis and labeling your y-axis, and then providing a title, or you can say providing a title to the chart. PLT legend is nothing but providing this legend, okay, the original yield and the interpolated yield for new maturities. And then this grid, PLT grid, is nothing but the grid line that you see, the horizontal and the vertical axis. And then PLT dot show is nothing but show this figure. Okay, so this is a way of plotting the yield curve using the cubic spline interpolation. Also, just wanted to show you the crux of the video. So always remember, cubic spline is always, it's curvy in nature, whereas linear interpolation, linear interpolation is nothing but it draws a straight line between 2 points. Okay, it draws a straight line between 2 points, whereas if you see cubic spline, this is, if you see, it is not a straight line. If you see, this is not a straight line. Instead, this is more like a curvy, it's more curvy in nature. So I hope this video has helped you in some or the other way. But this is how, guys, cubic interpolation, we can model the yield curve using cubic interpolation. So thank you all. If in case you have any doubt, please feel free to post it in the YouTube comment box, and I'll be more than happy to reply those, or solve your doubts, whatever doubts you have. So thank you all for listening till the end.